Okay, this is lesson 3.2 in pre-algebra, the addition property of equality. And we're going to drop down to the middle of the page where it says a solution for an equation is a number that when used in place of the variable makes the equation a true statement. So when I have an equation like x plus 3 equals 7, the solution is, what is the number that when I replace x with it, I get 7. Or this is a true statement. It equals 7. So in this case, when x equals 4, 4 plus 3 equals 7, that's a true statement. So the number 4 is a solution for this equation. So I'm going to be using the word variable a lot, and the word variable is just the letter that we're talking about. And when we have a variable, we're going to do a couple different things in this lesson. Let's first of all look at example number 1. And what they're doing is they're giving you a variable, and they're telling you what that variable, what number that represents. So they're saying a equals -2. And then they're giving you an equation. An equation is a set of numbers and letters with an equal sign. So when you're given an equation, they're asking you to find out what number can I replace that letter with in order to make that a true statement. So what they're asking here is, if a is -2, is that one of the possible solutions? We don't know how many solutions there are to this, but is -2 one of those solutions? Well, the way you find that out is you put in -2 for that letter. And you solve it using PEMDAS. So we're going to do a multiplication here, get -14. And 3 times -2 is -6. So now all we're trying to do is find out if -2 is a solution. So -4 plus 4, signs are different. We take the difference between the two. We put the sign of the largest number on there. -6 minus 2, or -6 plus -2. Signs are the same. You add them, put the sign, and we get -10 equals -8. That is not a true statement. So therefore, a cannot be -2 because it gives us a false statement. If that would have given us a true statement, we could say that, yes, a does equal -2. But that's not the case. All right, so let's go right into the addition property of equality. The addition property of equality says that if I add a number, let's say 3 equals 2 plus 1. Okay, so the left-hand side of the equal sign is 3, the right hand is 2 plus 1. And the addition property of equality says that I can add any number to the left side as long as I add that same number to the right side. So we're not going to have the same number because before I added the 14 to both sides, I had 3 equals 3. Now what do I have? 17 equals 2 plus 1 is 3, plus 14 is 17. So my numbers that are equal are different, but it's still a true statement. Our numbers are still equal to each other, and that's all we care about when we're using the addition property of equality. Are the numbers on the left and right, when we add the same number to both sides, equal? Yes, they are. They may be different numbers that are equal, but they're still equal. The same is true with subtraction. If I have 3 minus 2 here, and I have, well, let's get some bigger numbers here. Let's do 15 equals 20 minus 5. So those two are equal to each other. If I subtract 3 here and subtract 3 here, I get 12 equals 12 minus 5 is 15 minus 3 is 12. So as long as you do the same thing to both sides, you can add anything you want, you can subtract anything you want. It does not change whether or not they're equal to each other. So let's look at x plus 4 equals -2. This is example 2. All right, so what we're trying to do here is find out what number represents x. We have an x there, and we're trying to find what number makes that true. Well, if I plugged in, say, a -6, -6 plus 4, we have two signs that are different. We're going to take the difference between the two and put the sign of the largest number on there. And that equals what we have here. So I know that's a true statement. And I can kind of do that in my head. But let's use algebra in order to figure that out. So the rule says that we can add anything to the left side as long as we add that same thing, that same number to the right side, or we can subtract anything from the left side as long as we subtract that same thing from the right-hand side. So what we're going to do is whenever we're trying to solve for the variable, we do what is called isolating the variable, and that means we get rid of everything else except the variable on one side of the equal sign. So in this case, that 4 is causing us trouble. We want to get rid of it so that that x is all by itself. Well, how do I get that 4 to go away? Well, away. If I subtract it from here, it goes away. But I have to also subtract it here. If I do something to the left-hand side of the equation, I have to do the exact same thing to the right-hand side. So in this case, in order to make the plus 4 go away, I take it away. I subtract it. So that means I have to do it to both sides. So 4 minus 4 is 0, and that leaves us with just an x, because this goes away. -2 minus 4, or -2 plus -4, whichever way you're most comfortable with, is, I'm just going to use it as -2 minus 4, is x equals -2 plus -4. We add the two numbers together and put the sign on there, and we get -6. So we isolated the variable. We got it on by itself on the left-hand side, and we found out then, doing simple math, that x is equal to -6. So if you look at example 3 here, we're going to do some things before we solve for x. Remember, we talked about combining like terms. We have a 3x, and we have a -2x here, so we're going to combine those before we do anything. So 3 minus 2 is 1x, and then that -2, we can't combine it anyway, so we leave it alone. And we have 4 minus 9. And 4 minus 9 is the same as 4 plus -9. Alright, so let's leave this side alone. 4 plus -9. Signs are different. We take the difference between the two, put the sign of the largest number there. Alright, so we have a -2 right here. We want that to go away. So remember, when we have a -2, if we add 2 to both sides, that will make it go away. So we're going to add 2 to both sides. So remember, when you have a number with a sign on it, as long as you add the number with the opposite sign, the opposite number, then it will make it go away. It'll turn it into a 0. So make it so it doesn't exist, and that's what we want. As long as you do it to this side too. So right now we have -5 plus 2. So signs are different. We take the difference, put the sign of the largest number on there, and we get -3 for our answer.